January 2018, multiple choice, questions 16 through 20. Number 16, encircle M below diameter AC, chords AB and BC, and radius MB are drawn. Now the first thing that strikes me is that this is a diameter with an angle that intercepts the diameter, which means this has to be a right angle. This is 180 degrees. 180 degrees divided by 2 is 90. So that's a right angle. Also, this is congruent to this is congruent to this. So I have two isosceles triangles. Okay. So which statement is not true? Triangle ABC is a right triangle. Well, that has a right angle, so it must be a right triangle. Triangle ABM is isosceles. We already marked the radii congruent, so we know that triangle ABM is isosceles. Arc BC equals the measure of angle BMC. So this arc equals this angle. This is a central angle. Central angles are equal in measure to their intercepted arcs. So that is true. The measure of arc AB equals half of the measure of angle ACB. Well, that's almost right. This is an inscribed angle, but it's the angle that's half of the arc. So they've stated it backwards. So this is not true. It should say half of the measure of arc AB equals the measure of angle ACB. In the diagram below, XS and YR intersect at Z. Segments XY and RS are drawn perpendicular to YR to form triangles XYZ and SRZ. So these are right angles. Okay, and we know vertical angles are congruent. So what we really have here, for sure, is two similar triangles. We don't know anything about the sides, so we don't know that they're congruent. So when it asks which is always true, well, it could be true that they're congruent, but we don't know for sure. So we're going to cross off that the triangles are congruent. Okay, let's look at number 3 as well. Does XS have to be congruent to YR? No, it does not. We're looking for always true. So, let's deal with the fraction first. XY is out here on the left. That corresponds to SR. So this over this, that could be fair, equals YZ over RZ. Oh, YZ over RZ. Those would be corresponding parts, by the way. So I'm going with this one, but I'm going to show you how to deal with number 1. Okay? What this is saying is the product of the means equals the product of the extremes. We've heard that before in our class, but I don't think we've ever unpacked this before. So the product of the means, XY over something equals something over SR. So that would be the product of the means, and then the extremes go the other way. So we have X, Z, and then RZ. Those would be the extremes. Product of the means equals the product of the extremes. Now let's take a look and see what this actually is. So XY is out here, and XZ is here. So you can write a proportion where you do something on itself over itself. But the problem is that XY, when you go the other way, does not correspond to RZ. So if you're going to do same over same, left over left, it equals right over right, then when you go across, they have to be the corresponding parts. Instead of having the corresponding parts with each other, they have to be across equal to each other. So XY does not correspond to RZ, so that doesn't work. Okay. Number 18. As shown in the diagram below, ABC is parallel to EFG, and BF is congruent to EF. So this is congruent to this, which means we have an isosceles triangle, and when two sides of a triangle are congruent, the base angles are congruent. So that's something you should add right away. The parallel lines are going to give us some cool stuff like alternate interior angles, so that means that this angle is actually also congruent, because alternate interior angles are congruent. Okay, so if the measure of angle CBF is 42.5, CBF, 42.5 degrees. All right, so that makes this alternate interior angle 42.5 degrees. And so if I take 180 and subtract 42.5, I get 137.5, and the two remaining angles are equal, so I'm going to divide by 2. So that makes each one 68.75. So this is 68.75. This is 68.75. Okay. And that makes this also 68.75. And just for kicks, I might as well find some other things here. This is 111.25. And this is 137.5. It says, what is the measure of angle EBF? EBF, 68.75. So I'm going with number 2. A parallelogram must be a rhombus if its diagonals do what? Hey, there's a quad quiz question. Pretty much, they're saying it's not a rectangle. It's a parallelogram, but it's not a rectangle. What would make it a rhombus, but not a rectangle? Well, congruent diagonals are a rectangle. Diagonals bisect each other. That's actually both. Do not bisect its angles, or are perpendicular to each other. So let's do a sketch. That's a rhombus. Those are looking pretty perpendicular, even though my drawing is sloppy. Okay? Let's do a rectangle. And those angles look like they're bisected as well. So that says do not bisect its angles. A rectangle does not bisect the angles. And the diagonals are not perpendicular. So, it must be a rhombus if the diagonals are perpendicular. What is an equation of a line which passes through 6, 9 and is perpendicular to the line whose equation is 4x minus 6y equals 15? We've done a ton of these. All right, so the first step is to get y alone. Positive 2/3, sorry, x minus 5/2. Okay, so we need, for perpendicular, we need to take this slope and flip and negate it. So our perpendicular m is going to be -3/2. Look at your equations here. We can eliminate 2 and 4. Those would be parallel lines. Okay? And then we need it to pass through the points 0.69. So it's the y you need minus the y you know. That's -9 equals your slope that you need times the x minus the x you know. I'm going with 1 and not 3.